Hello. So today I thought I would go over Scikit, another one of our tools for machine learning, in a little bit more detail than is in the book we're using. So here you can, if you go to the Scikit website, there's a link to scikitlearn.org, and here you can. There's a good overview of what Scikit does. So we're going to go basically through that today. And so the first thing they talk about is the idea of the problem setting for machine learning. And there's two types of machine learning: supervised learning and unsupervised learning. And the key with this is basically whether or not you have result data or not. So for example, you maybe you have a set of data which lists the attributes of some problem area that you're working on, and you have in that table you also have the element that you're looking to get the result for. So for example, in a typical sales situation, you might have attributes of different customers, and then you have whether or not they purchased something or not, or how much they purchased. Then in that instance, what you would have there is an example of as a good data set for supervised learning, because you have the results. With unsupervised learning, your training data consists of a set of input vectors without any corresponding target values. So you're really just looking for patterns, essentially, in the unsupervised learning. You're looking for patterns in the supervised learning, but you have the results. So supervised learning works really nicely when you have some good research data. And so under supervised learning, we have two areas that we can look at: classification and regression. And classification occurs when given two classes of that we're observing, and giving data that relates to those, later on, can we take data and then infer which class something belongs to? So that's classification. And then an example that they cite there is handwriting digit recognition. And so there we're trying to figure out which character is being represented. And so the two more classes, in this case 26 characters, the letters of the alphabet, and we're trying to predict which letter of the alphabet a image is. So if we had, for example, a whole bunch of sample images of handwriting, we could use a classification approach to do that. Regression is basically where the output consists of one or more continuous variables. And so, this is an example where you have, a problem would be the prediction of a length of a salmon as a function of its age and weight. So if we had a table with age, weight, and the length of a salmon, we could actually use that to, and with regression, the simplest example is linear regression, where you would say that as age increases and weight increases, the age of the salmon is likely to be older, and so you would map you would map the relationships between age, weight, and age as a linear representation, and then you could apply that linear formula to predict, based on age and weight of another salmon, what their likely age was. So classification, where we're trying to figure out which group something is based on the data we have. Regression, where we are predicting a result from known values. So given those different types of machine learning, what scikit-learn is going to give us is a bunch of tools to process that data. Now, you could do those things by hand, and you could write those formulas up as a program from scratch. But that's why we have libraries like Scikit. They do that for us. And And a common practice when using this, and the way Scikit kind of works, is we're going to take a data set, so a single table with data in it, and we're going to randomly split it up into two groups. A training set, which we're going to use to try to figure out the pattern, and then a testing set, which is basically just random selected elements of the original data set. And we can use that testing set to calculate how good our training set is. And so by doing that, we not only come up with a model, but we also can estimate how good that model is to be used. So with that, let's create a new demo. We'll call it Scikit Demos. And in here we'll open up our Visual Studio Code. We'll do this all in Visual Studio Code. And I'm going to create a virtual environment and do all that setup to make it a little easier to set things up. So I'll create a terminal. I will set up my virtual environment. And again, if you want to get the documentation on VENV, just type VENV Python and you'll find the documentation here, and it gives us the format for writing this command. We don't need to put Python 3, at least on mine, so I'm going to just put VENV as the name of the directory I want. And so this is the directory name. It's going to show up here as a new directory with my virtual environment. There's my virtual environment. It's going to load that up with everything I need, so that if I install any anything that dependencies, they'll be in this one folder. The disadvantage, of course, being that the virtual environment will take up more space. The advantage being that I don't have to worry about loading up a later version later on and then having it mess up. And then I like the idea of having an imports file, so I'm going to create a file. And actually, it's kind of interesting. There's also good documentation here under view, search pip and install packages. You can find good documentation on virtual environments here as well. And then for the requirements file, we're going to make a requirements.txt file. I'm going to place it in the... Nope, that's not where I want it. Yeah, I guess that is in the right place. So we're going to create requirements.txt. And I think we're going to need pandas, and we're going to need, we want Scikit looking this up. So what I'm looking for here is okay, it's scikit-learn. And scikit-learn has these dependencies. So let's see, is pandas in here? I don't see it. So I think we need to put both of these in. So this one will be scikit-learn. We'll save that, and then now that we have that, there it is, requirements.txt, we'll say pip install -r, if I remember correctly, requirements.txt. And this will now install all of these requirements. Oh shoot, I forgot to, before I do that, I need to activate my virtual environment. So we're going to say venv/scripts/activate, and that's going to call this script here. This activate script is basically going to set up our virtual environment. So now we're in virtual environment, and then I'm going to do pip install requirements so that I can see all my dependencies for my libraries I need to work on this stuff will show up there. Almost need like a script to do all of that setup initially, since we do this stuff a lot. Anyway, but not bad to learn to type it over and over again and just memorize it that way. So you can see all these libraries that we're going to use, that we need for scikit, end up showing up in here. And if you, just out of curiosity, if you look, you can see, there's pandas, there's SciPy. I think that's one of them. Is that in here? All right. Let's see what else it's bringing in. NumPy is one of them. So these are all just libraries, and one of the things you can do for to learn this in more detail is actually go through and look at these different libraries and do their tutorials as well. Never short of tremendously cool things to learn in programming. Okay, so now we've got a virtual environment, we've got our requirements, we're running in our virtual environment down here. I guess we can close that out. Now let's make a new file. We're going to make a Jupyter notebook, and we'll call this one scikit demos dot ipynb, I think it is. Yep, ipynb is the extension for Jupyter Notebook. If you don't remember it, you could just look up extension Jupyter Notebook. Nice thing about Visual Studio Code, it's really not, there's very little ceremony to make these things. You just add a file with that extension, and it's got everything loaded in. And we do need to have the Jupyter Notebook library loaded. I think it's one of the all the cajillion things I have loaded in here. Yeah, I've got the Jupyter Notebook and Jupyter Key Map extensions loaded. So those extensions are helpful, of course, when working with these. And then we have our markup. And let's see, can I switch this over to markup? Or mark down, I guess. It's not markup, it's marked down. So let's see, for our demo, we're going to, so in this introduction they have some tutorials. There's some standard data sets that are available to download from scikit-learn, and let's do an import. And see if that works. So the environment we're going to pick is, that's pandas demos. We want this one down here, scikit demos. Make sure you pick the right one, because then otherwise you will be grabbing the wrong data set. sklearn. So we'll say from sklearn import datasets. And we'll say iris is equal to datasets dot load iris, and we'll say digits equals datasets dot load digits. Looks like there's actually a number of datasets in there, and we'll run that to see if we. And then it's going to ask for IPY kernel for, so just go let that install. So what do we find out about these data sets they gave us? If you go to sklearn and search for the data sets, for example, what I did is I just searched scikit data sets, or sklearn, probably going to put sklearn data sets, and it tells you about the data set. You know, there's 10 classes in here. Digits make sense, 10 elements, so 10 classes 0 through 9. And each class is 180 samples. And they're all basically like this, 8x8 pixels with different color values that represent numbers. And so you can use this to read numbers from an image. So you can, you know, if you think about it, we have all these 8x8 matrices with data related to our numbers. How does we use classification to do that? Well, if we could trade up a model that would take a 8x8 matrix of grayscale values and would predict which one of the 10 classes that data most closely is associated with. Well, there you have image recognition. So what do you have to do? Well, if you have an image and it's 300 by 300 pixels, how do you? Well, you have to take that image and you have to process it initially so that it fits this pattern, so then it'll fit in. So there's a bunch of there are things there to do that process. So, but we're going to so that's the purpose for this data set, for making that model. And so this is just a data set. So once we have this, let's add another code block here, and I'm going to do some markup here. Let's see. There are these, if you want to know how to format your Markdown, there are these guides here. This one's from Medium, where you can search for Markdown syntax that will format things. So I'm going to start using some of this just to make things look a little bit better with my Markdown. And let's see, so once I do that, I hit Control Enter, and now we can see that this is now looks nice. So maybe I'll add another Markdown element here. So that's, and let's see, probably want to look up scikit sklearn iris dataset. And let's see, what does it tell us about this data set? This data consists of 3 different types of irises. And so I'll copy that and put that into my markup. So now I have some documentation about what my data sets are. In many ways, a Python notebook is a notebook. So it behooves us to explain what our code is as we're going through. And so the next thing I want to do is, let's see. I've got my example data set. Let's display the data set. And for that, what we'll do is print digits.data. And I'm hitting Control Enter, by the way. I don't need this window anymore here so I can see what's going on. So there's the data. Let's see what happens if I put toString. It doesn't have it. Okay, because it's a list of lists. I'd like to display the whole thing. I think they're going to give us something here. So let's try this. Say digits.target. So those are this is the array of okay, so target is going to give us basically the where did we get target from? So digits. This is target's going to give us what the index elements are of this thing, and then what we can do is say digits.images, that's 0, and look at so here we have an 8 by 8, 0, 1, 2, 3, 4, 5, 6, 7, so 8 elements starting with index 0, and then we have 0, 1, 2, 3, 4, 5, 6, 7. So we have floating point numbers. You can tell because I put a dot there. And those are the color values or the grayscale values for that image. And what we can see is this is a 0. Let's look at what the 1 looks like. Yeah, you can see a lot of color value here, a little bit extending out here and a little bit extending out there. Let's look at a 9. And you can kind of see the 9 just by looking at the numbers. It's like looking at the matrix. So this is pretty cool. So basically we have, let's see, what's 11 give us? Yeah, 11's another one. So it's basically, it looks like it's just every number repeating. With the image color data as a matrix. So we've got this this image data. What can we do with this? Well, we can use it for prediction, and to do that, we're going to add a code cell. And from our sklearn library, we're going to import SVM. What's SVM? Support vector classification is what SVM stands for. And it provides us these things called estimator classes. And you can go through and read the documentation on what these things are. So they link to a number of these Wikipedia articles, which can which can clarify what these things are. So basically, so SVM is a supervised learning model, and what we're going to see is that Scikit basically gives us a number of different types of models, and depending on what your problem is, different learning models are going to be more appropriate for different types of problems. And so this one is good for picking out boundary layers on shapes. And that makes sense when we're trying to figure out a shape like numerical values. So let's see what happens with this. So we're going to pull in the SVC model here, and you're going to see this pattern with, we're going to make a classifier, SVM dot an SVC model, and support vector classification. It's based on libsvm. The fit time scales at least quadratically with a number of samples and may be impractical beyond tens of thousands of samples. So there's a limit on how large a data set we can apply this to. And for now, we're just going to set, we have to set a couple of attributes or parameters for this model. And we're going to set gamma equal to 0.001 and C equal to 100. They provide some links on how to tune those. And you can read through those, but we're going to just use this to do our demo initially, just so we can see basically how these work. We can get into the details of specific models later. So we have this classifier, and then what you do is you do a fit operation. So you say classifier dot, and all these classifiers will have a fit model, and then what we're going to do is we're going to put in our digits dot data, and we're going to go through all of the data elements except for the last one. So we're going to go from the beginning all the way to -1. So just remember, when we do slicing, it's inclusive, exclusive. So it's including of the beginning, but not inclusive of the very last element. And then, so fit takes what are the input. So basically, fit takes a table of inputs and then a table of outputs. And for the outputs, we're going to pick -1. So what is that? So if we go back and look at digits.data, we got this. And so let's, probably the easiest way to look at this is just print it out. So before we get here, let's print digits.data and see what that is. So I'll run that. And this is digits.data right here. And I'm going to comment this out temporarily just so to make sure that I'm getting. No, I don't need you to run here. Okay. And let's see what digits data from everything to -1 looks like. And then see what target looks like. Okay, so the digit, so this is going to give us all the shape that arrays, and then this is going to give us the result, whether it's a 0, 1. So all of those will each have a particular result, or each of these shapes like this will correspond to one of these, and this is fitting. Given this shape, it's giving its CLF is being this model is being fitted. In other words, the attributes of this model are being configured in such a way that it will do a good job classifying. If we provide an image, what the resulting number would be. So once we have that, then what we can do is, so let's put some comments in here. So we're going to fit the model here. We're going to instantiate the model, fit the model, and then use the model to predict. CLF.predict and so we know what we're looking at. Let's do this. Let's do a print and run that. And basically it's saying, hey, given this array of values, I'm going to predict that's an 8. And we could even do this. We could say, let's say my number, make a variable, is equal to and let's see how they set this up. Digits. So 1, 2, 3, 4, 5, 6, 7, 8. So I'm just going to try something here. I'm going to put 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6, 7, 8. And let's try this. Predict. I think this is going to be wrong initially. I need to make some adjustments, but just to give me a starting point. Yeah, so let's try, maybe this needs to be in a list. $65, $56, so am I missing one set of features? Yeah, so this is the prediction of that one. This is so this thinks this is a 1. Which is interesting. 3, 4, 5, 6, 7. Ah, I see what I did. So I need to do this. I didn't have 8 per line. That's why this was messing up. Okay, so let's try this. Okay, so let's see if I put so now I've got 1s around there. Let's see. It looks like they want bigger color value. Oh, let's see if it picks it up. So Control Enter. Oh, look. Well, now it thinks it's a 1. Let's increase this these to 15s. See if we can get it to pick it up as a 0. May not work, but this is one way of kind of seeing if we got the concept. Still reporting it as a 1. This is obscuring, so I'm going to take that out. Yeah, it's still predicting it as a 1. I would have thought I'd pick it up as... Maybe I need to put dots, make sure that this is registering as... It's expecting floating point numbers. The integers may be messing with it, so we'll make sure data looks like what it's expecting. Still thinks it's a 1. Okay. My experiment didn't work so well. I would have expected to pick that up as a 0. Let's do this. Let's print digits. Got images 0. Let's just see what that looks like. You know, it may be, I think I'm just going to take this and put it in here so that now I'm hard coding in. It doesn't, when it prints it out, it doesn't put the commas between things. Let's see if it will do, if it'll handle this. What I'm trying to do is try to get a manually built array of data and see if I can get it to pick up on what I'm trying to write. I think this might, yeah, value 64 features. So it's expecting this to be one continuous list of numbers. So we're going to shape it that way and see if that works. Put this back in. And now it found it. Okay, so now it identifies it as a 0. So we could, let's say we want to make this into a 2. So maybe what I do is I do this. I take this and we'll break that up there. And we'll start changing the data, making it look like this. And then I'll put a diagonal going up this way. So now we have something come across here, comes across there. I want some more zeros in here. Which basically, it's like the worst paint program in the world. And let's see what it does. Let's see what you do with that. Ah, yep, it found it as a 2. So I basically kind of drew a 2 out there, and I know it's kind of hard to see, but it is taking these shapes, whatever I put in here, and kind of getting this in there. So you can have fun with this, you know, just kind of make your, put some numbers in here, and just move the values around a little bit. I think I'm going to try to make a 1 now. And I don't even have to be very, very precise here, right? At some point this turns into a 1. Yep, it turned into a 1. So, so that's what a classifier is doing. All it's doing, so what we have with IntroToScikit Learn is a mathematician figured out how to make this model. Scikit-learn has a whole bunch of classification models available to it. We create a model In fact, it probably, you can call it, these anything you want. So maybe if classifier doesn't make sense to you, maybe just call it a model. And then we're going to fit our model to our data. And so this is the input data, and then this is the target. Once we have that established, what we can do is I like my example better than what they have because it's more visceral to know that, okay, I wrote this. Then we pass something new in, and it does a prediction on it. And if we've done things well, it looks at this and predicts what it is pretty well. So that's basically what Scikit is. It's a collection of classifiers, and we are fitting data to our model. So to get a better understanding of this, I recommend going through the tutorials in Scikit-learn. And when you go through the exercises, there's an additional step. There's additional couple steps that that's the book that we're following does, which is it often takes a big data set and has that train test split. It's making two data frames to pass in here. And so so you create a model, you take your data, split it into two parts. One with, just randomly, you basically are randomly taking maybe 30% of the data to train with. You're passing that training data to do the fit, and then later on you use the remaining data to measure how good your fit was. So there's a good user guide, and you can look up the models you're using. So linear models, we've used a linear regression model. They'll have explanations of what it is and how that model works. And so reading through that material as you use the model will help you out. And the way to get good at this is, my course is going to give you an intro to how this works. Really, over time, the best thing is to try to use it to solve real-world problems. So, periodically grabbing a data set, figuring out a classifier that seems like it would work best for it, setting up and fitting your model, and then doing some predictions on it, and maybe making a little website to allow you to play with the predictions. So hopefully that helps clarify a little bit of what we're doing with Scikit, and gives you a pathway to explore it in more detail and get a better understanding of what the demos and the books are doing. Thank you very much.